Hello everyone, my name is Amy. This is Hector. We are both front-end engineers here at Paddle, and we're going to be talking about how to use web components with React. So we'll start off with what are web components. The literal definition is they're a series of browser standards defined by the W3C, allowing developers to build components in a way the browser can natively understand. So it's basically a combination of 3 browser standards: HTML templates, shadow DOM, and custom elements. First off, HTML templates, they allow developers to declare a section of markup without directly having it render until it gets duplicated. So yeah, templates, they declare a section of markup without directly having it render until it gets duplicated. And so in React, it's basically like JSX, where you create and use it later on. And slots, they allow developers to dynamically place custom HTML content with the templates. So kind of like children's site in the React component, and it gives us additional. Okay, next up is shadow DOM. So it allows the web browser to render DOM elements without putting them into the main document tree. So it's like an isolated and self-contained DOM. It creates scope CSS, so the CSS defined in the shadow DOM is scope to it, which prevents styles from being outside of the component and into the main document tree. And if you wanted to do like a React equivalent, it'd be like creating dynamic classes or inline styles. And this is just a small example of a shadow DOM. You can see there's a web component there, and the shadow DOM is attached to it on the top. And lastly, we have custom elements, which basically just wraps the HTML templates, slots, and shadow DOM together in its own named reusable element, which can then get used as a regular HTML element. And you can create customized built-in elements that are built upon native elements to reuse their functionality, or you can create autonomous custom elements, which are built bottom-up and entirely separated from native elements. This is just an example of a custom element that extends the native HTML paragraph element. It will inherit the base properties of an HTML paragraph, and you can add in any additional behavior that you want. We just wanted to go over a couple of pros of web components. They are reusable. You can obviously reuse the elements you create. They're extensible. They're built upon native HTML elements, or you can even build upon your own components that you create. They're scoped to DOM and CSS, which prevents styles from leaking and worry less about CSS naming conflicts. And lastly, and most importantly for us, they're compatible. So web components are built on web standards, so they should be able to work in any application. And with pros, there's a couple of cons that we wanted to highlight. It's still relatively uncharted territory. There aren't as many resources available online from other developers, and the community is still quite small, especially compared to React. There's added complexity. We have to think about adding additional interfaces, and the integration with React isn't super smooth right now, which we'll get into a bit later.
Okay, so we still haven't answered the question, why did we build a component library? Because we have one component library here at Paddle. And why did we do that, like having like 1,000 million component libraries out of the box out there? So usually developers, we have like this kind of delusions of like greatness, and we just want to build things from scratch. And we say, like, we have Material UI, but let's screw Material UI, we're going to do our own component library. In our case, it was justified. There was a business case for a component library. So that's the situation at Paddle. Oh, there was like nice gradients and everything, and they're gone. You know, just like bear with me with this. So this is where we are right now, or where we were like half a year ago. Basically, we have like a control panel at Paddle for our users to use, and it was built entirely with Laravel, blade templates, Laravel, and so on and so forth. But of course, because we are here now, we wanted to get there. We wanted to have everything with React, have a nice progressive application. The problem is that building this with React, rewriting the whole thing, it would take like realistically 1 year, really 3 years, or something like this. So we couldn't do the whole thing. We couldn't do just like rewrite the whole application. Right now we are here. There's in theory, in my mind, there's a nice line going from here to here, and there's like, but we are here. We are like a 10% of rewriting from Laravel to React. But what's the problem with having like two systems? We have one system when it's like monolith, the other one is React. What's the problem with that? That the systems diverge. They stop being consistent at some point. And you know what happens with components, that components, by the way, I did that. I didn't take this from the internet. This is the best slide that I've ever made in my life, you know? I've even like created like the whole buttons and everything. I mean, and this shows you that I am pretty old, because do you remember these buttons? 2008 buttons with like a gradient and a Comic Sans thing and I'm so old. Okay, anyway, you have to be there. Anyway, components evolve, and they evolve like super quick. In a relatively like brief period of time, styles, they change. What looked like really great 2 years ago, now it looks a little bit like non-fresh. What's the opposite of fresh? Non-fresh. So what could happen? What could happen is like we are there, and at some point we end up being here with two systems that are different, they look different, they behave different, and this is like a terrible user experience. We wanted to prevent what we call here the critical threshold of Frankenstein S, you know, which is this moment in which like the two systems are so different that they look different, and this provides like a really, really bad user experience. So how can we build like a component library for a monolith, for Laravel, for Blade templates, and for React? We had several options. One option was like having something like Bootstrap. Not Bootstrap, something like Bootstrap. Having a set of CSS elements and JS elements. We just like put them in the site, and they give styles to everything and so on and so forth. But this is not great because it's a burdensome to deploy. Bootstrap, it has this really weird kind of loose markup dependency between CSS and JS, which is not great. It gets like stolen like pretty quick. It's not like scalable. And right now the problem with the monolith is that we already have like a bloated CSS system, so we didn't want to add like Bootstrap on top of it. So another reason that Sol, one of the engineers here, mentioned, and he nailed it, is like you need this to create a model with Bootstrap. The yellow bits are like dynamic bits, whereas in React you can do something like this. You know, you just like pass the title as a prop, put the body as a child, and you're done. React takes care of the rest, and we wanted that for our component library. So we had the option of like just embracing the monster and going for React only, but then we're gonna have like this kind of diverging system. But someone at some point, I think it was Sol too, he said, why don't we use web components? So when someone mentions like web components, your first instinct is to fire this person, you know? But before firing him, we decided to actually like think about it, because I remember the last time I took a look at web components, it was like 1 year ago or something like this. The landscape was terrible. It was not supported, no ecosystem. The only thing was Polymer. I'm laughing just by saying Polymer. The only thing was Polymer. It was pretty weak. But now we took a look, and I thought, okay, I mean, there's a lot of red in here, but this is like pre-polyfills. So if you use polyfills, you can go as low as IE10 or something like this. But now that Edge has joined like the forces of evil, actually we also have web components with Edge. We have web components with Firefox and Chrome. Our users are pretty much like power users, so we can trust them to doing kind of the right thing. Then somebody said, okay, why web components? Aren't like React components and web components exactly the same thing? And I was like, well, even like the React docs, they have like a part of the documentation that says React and web components. And they say React and web components are built to solve different problems. So web components provide strong encapsulation for reusable components, what Amy just said, while React provides a declarative library that keeps the DOM in sync with your data. The two goals are complementary. They are not the same. They can be used together. So after like some thinking, we decided, why is this arrow showing up and not the other ones? That makes sense. Okay, anyway. So we said, okay, let's try that. We like spiked for a couple of weeks. We experimented. It looked amazing. It was quite pleasant to work with. So we decided to like run with it. By the way, we're using Lit Element. I don't know if you've heard of it. I think that first release version was in February, something like this. It's a really thin, basic class built by Google, and you can build your components on top of it, and it's amazing. I mean, on top of like other niceties, it offers a way to actually specify templating in a declarative fashion instead of imperative. Like the Web Components API is super imperative, but you can do this kind of stuff. You can make templates with string literals, and it's actually really nice. So, okay. The monolith was solved. We're going to use Web Components. What about React with Web Components? So there's this nice page called customelements.everywhere.com. And it tells you how nice your JS framework plays with Web Components. So actually, it's pretty good. Vue, it says, yeah, 100% use Web Components with Vue. It's amazing. With Angular, it's amazing. With Polymer, it's pretty good, 91%. What about React? The React is the worst of all. It's 71%. It has a lot of problems that actually Amy will talk you through now.
Yeah, so we'll briefly go into one of the reasons why React isn't doing so hot as far as integration goes, and that deals with handling data. So custom elements allow us to work pretty low level here, but that means we have to handle our own properties and attributes. So just a refresher, we define attributes on HTML elements, and the browser parses the code, a corresponding DOM node will be created, and this node is an object that has properties. And let's note that attributes are always strings. So Google suggests as a best practice for custom elements that we should aim to only accept rich data as properties, because it can be expensive to serialize an object to a string, and any object references will be lost. The problem here is that React passes all data to custom elements in the form of HTML attributes, aka strings. So this works fine for primitive data, but not for objects and arrays. So here, I want to create a page header web component, and I'm trying to pass in valid headers as an array and a mock data object. You can see that the attribute values get stringified, and our data ends up looking like that, which we can't really do much with. So there is a GitHub thread for how React can handle properties and attributes with custom elements for React 17. That is in the future. So in the meantime, we basically have two options. We either find a good way to set properties on our web components when we use them with React, like creating a wrapper to inject the properties when the component mounts, or we can avoid having rich data in our web components altogether. And if you remember, our use case here at Paddle is we're trying to create simple components that we can build upon versus complex components that have a lot of functionality. So we basically decided to change our mindset a bit by creating our web components similar to native HTML elements by replacing slots.
Yeah, so essentially we solve the problem by not solving the problem and being absolute cowards. So we have this kind of principles every time that we need to build a component. First, it needs to be essential. It needs to be useful for both the React applications and our monolith. It needs to provide immediate, tangible value. We don't have a team of 10 people entirely devoted of building a component library. It's something that it's a lot of effort for us. So every component that we build, it needs to be useful now. It needs to be super value for us. It needs to be useful and understood by everyone, because this is a company-wide effort. Building a component library, it's a big effort, and it needs to be a company-wide thing. It's something that everyone needs to be involved. They need to be easy to implement, because the fact that they are so close to HTML components, they make them useful for like people that don't know anything about React. So you can just like add like a script tag in your header, and you can use this kind of HTML-like components that you can use in your like HTML page, and they work. And this is amazing because people from operations are going to use them. People from building like internal stuff are going to use them. So it's a company that's going to sound really wonky, but brings the company together, you know. But they need to be really close to the metal. So we cannot use like super fancy, super complex components. They need to be like really specific, small atomic things. For example, with React, you could do, I want a page list. I'm going to pass you an array of items. You do your thing. With this, we have to do, I want to do a page list, and then we have to create this kind of list items components, and then you pass a string, something like this. So you have to be really nimble. Everything needs to be with composability in mind. I don't know if we have time to do like a little bit of a peekaroo in the component library. I can send you the link later. This is basically, we built a storybook with all of our components that we have right now. We have a small collection of components. We have 6 or 7 right now, but they are in production, which you can put in your like LinkedIn profile. I have web components in production. That's gonna be great. Finally, just like some questions that I wish people had asked us before starting a component library. First, what do you want from a component library? So not all component libraries are the same. People just like get like Bootstrap or Material UI, but this doesn't like, it's not useful for their business value. So what do you want your component library for? For us, it was like we need to bridge we need to bridge like some really different systems. We need to something that applies to everything. So that's our use case. But you have to think what is yours. What resources do you need to build one? We thought 2 developers, 3 weeks, enough. That's not enough. It's a lot of work because it involves product, it involves design, it involves like a lot of stakeholders that they want to participate because it's an exciting project. Are web components a good choice? It's a good choice for us, but maybe for you it's useless because you're just using React. So think about the ultimate use case. And then which kind of components do you want? It's like what I said. Do you want super complex components that do everything for you, or do you want to compose things into small atomic stuff? So there's a lot of variables to think before actually embarking yourself in an adventure, which is honestly a huge pain in the ass. It's really complex. So that's it. Some Lego bricks. Any questions?